inequalities, the approach is going to be identical that we took with our parabolas. Don't forget that it doesn't matter whether we call this axis f of x or y, maybe p of x if it's a polynomial. That's my x-axis. This is my y value. So if we want to know where the equation is less than 0, I want to know where is the equation below the axis. So this is less than 0. So that's doesn't matter if it's f of x is less than 0, p of x is less than 0, y is less than 0, or even as in this case, x cubed plus x squared minus 5x plus 3 is less than 0. It's all this section down here. If I want to know where any of those things are greater than 0, it's all that section up there. So that's y greater than 0. I don't know, x squared plus 2x is greater than 0. That section above, all right? So the process, we have to sketch the graph first. How do we sketch a graph of a cubic graph, or a quadratic for that case? We factorize and solve equal to 0. That gives me my x-intercepts. So to factorize, first things first, we need to find a number that substitutes in to give me 0. So if we look at the coefficients, 1, 1, 3, and 5, I think P1 will work. So if I say that polynomial, we'll just call it P of x. If I work out P of 1, I'll get 1 plus 1 minus 5 plus 3, which is equal to 0. Therefore, x minus 1 is a factor. So if x minus 1 is a factor, I do my division, which in this case will be synthetic. Positive 1 out the front, I've got a 1, 1, negative 5, and 3. Bring the 1 down. 1 times 1 is 1, plus them together I get 2. 1 times 2 is 2. Add them together is negative 3. 1 times negative 3 is negative 3. Add them together is 0. There's my remainder. Confident I've done it the right way. So that gives me now a 1x squared plus 2x minus 3. So if I factorize this, I get x plus 3, x minus 1. So that means my equation can be written as x plus 3, x minus 1, and another x minus 1 from the start. So it's equal to x plus 3, x minus 1 squared. So we can see, hopefully, after we've started doing a little bit of practice, my intercepts are going to be, all right, x equal to negative 3 and x equal to positive 1. The important thing to note about x equal to positive 1, it's a squared factor, so that's also going to be a turning point. So let's sketch the graph. Negative 3, so we'll make that one there, negative 3. Positive 1, make that one there. What's my y-intercept? If I come up here, put x equal to 0, 0, 0, 0, I get plus 3. So 1, 2, we'll call that plus 3. So there's my graph. Now I want to sketch my cubic, positive cubic, so it's going that way. So very quickly, so below the axis there, above the axis, turning point could be anywhere, not sure, and going up. So you can see the black line is below the axis, that's where the function is less than 0. The red line is where it's greater than 0, and we'll call the blue dots where it's equal to 0. So what's my question say? Use the graph to determine the values where it's less than or equal to 0. So that point there is negative 3, that point there is 1. So I need, what do I need? I need all the values that are less than negative 3, including negative 3, but also the point at x equal to 1, because that's where it's equal to 0, okay? So both of those sections satisfy where the polynomial is less than or equal to 0. All right, off you go.